Hey guys, this is Worm from Worm's Master Academy. I hope your afternoon was better than what mine was. I spent the afternoon painting um, my new venue in Narre Warren. So I'm assuming the exam probably wasn't too much fun, although I saw some clown on Facebook say that it was easy. It was the easiest exam in the last 10 years or something. So I doubt that very much, but I don't know. Let's have a look. Okay, first question, the period and range of the function respectively. So our period is 2 pi on 2 fifths, which is 10 pi on 2, which is 5 pi. And our range, our center is -2. If we add 3 and subtract 3, we're going to get 1, -5. So -5 to 1 and 5 pi are B. Set of values for k, for which that has two real solutions, is our discriminant, b squared, 2 squared. If I can get this stupid thing to rub out. 4 minus 4 times 1 times -k has to be greater than 0. So 4 plus 4k is greater than 0. 4k is greater than -4. K is greater than -1. B squared minus 4 times k. What have we got? It can't equal -1 because we want two solutions. Average rate of change from 6 to 8. A on x minus 4, 6 to 8. A on x minus 4. Define f of f of 8 minus f of 6. I might be a little bit high from the paint fume still. -a on 8, was it an answer? It is E. 0 to pi on 6, a sine x plus b sine x is equal to 0 to pi on 6, 0 to pi on 6. I hope I haven't got nothing. A times, don't forget to put a times, sine x plus b times cos x, was it? Be nice if I had another copy of this so I could look at it. Cos x dx. Simplify. What's that there as an answer? Eek. Okay, b plus 2a minus root 3a. b plus 2a minus root 3a on 2. Where the hell is that answer? Positive b. That's plus root 3. It's not that. Not a minus b. 2 minus root 3a on 2. Yep. Okay, let f dash equals that, such that f of 4 equals 0. So we know x cubed minus x squared plus c. If we put 0 into that, we get the rule of f is f of 4 is 0. 0 equals 64 minus 16 plus c. C is -48. So C. Rectangular sheet of cardboard, 80, 50, 80 by 50. Side lengths that. Rectangular boxes with an open top is the volume of the box is a maximum when. Okay, so dimensions are 80 minus 2x, 50 minus 2x, and x. So 80 minus 2x times 50 minus 2x times x. That's my volume. My x values have to be between 0 and 25 just by solving those functions. Calculation f max, 0, 25, 1800 when x equals 10. X equals 10. The volume of the box is a maximum when x equals 10. Discrete random variable has that probability distribution, A, 3A, 5A. That's at 16A. 4, 9, 16A. A equals 1 on 16. So we get 3 on 16. 2 times 5 is 10 on 16. 3 times 7 is 21 on 16. What's that? 34 on 16. 35 on 16. I've missed something. 3, 10, 21. The mean of x is, what did I say? 34 on 16, which is 17 on 8. Hadn't missed something. Okay, an archer can successfully hit a target with a probability of 0.9. The archer attempts to hit the target 80 times. The outcome of each independent of another. Given the archer successfully hits targets at least 70 times, the probability the archer hits a target exactly 74 times. Correct to 4 decimal places is 74 greater than 70.9, 80. Okay, so we want to first put a divider because it's a given question. So exactly 74 times, 80 trials, 0.9 success. And then greater than or equal to 70 calculation, no, what the hell am I, distribution, discrete binom CDF, 70, 80, 80, 0.9. Now, at least 70 times, so 70 or more, 0.1494. So it's the probability that x equals 74, given x is greater than or equal to 70. That looks good. Okay, the point AB is transformed by the image of AB is 0, 0, so it becomes 0, 0. So x dash is 1/2 x minus 1/2. Y dash is negative 2y minus 2. It becomes those points, so 0 equals 1/2 x minus 1/2. So x equals 1, 0, oh you stupid thing. Zero equals negative 2y minus 2, bring that to the other side, 2, and then we divide it by, so y is negative 1. So my original points must have been y negative 1, 1 negative 1, e. Let's see if we perform, bloody rub out you piece of crap. Okay, if we perform these, so if I've got the point 1, negative 1, if I dilated 1/2 from the y-axis, that would become 1, no, would become 1/2, negative 1. If I reflect it in the x-axis and dilate it by factor 2, I would get 1/2, 2. If I translate it left 1/2, I'd get 0, and if I move it down 2, I'd get 0. That's right. Okay, which one of the following statements is true for x plus sine x? What does x plus sine x looks like? It's just like an increasing graph, I think. X plus sine x. And zoom, initialize. Zoom, order, let's have a look. So it's just increasing. Has a horizontal asymptote? No. There are infinitely many solutions? No, because it was increasing. F has a period of 2 pi. Didn't look like it had a period because it was not repeating the same graph over and over. F dash of x is greater than or is equal to 0 for all x. Easiest way. That looks right. Analysis G solve. Min. Okay, that's at 0. So that's right. The gradient's always positive. A and B events are from a sample space such that the probability of A is P. A, so that whole thing is P. The probability of P is greater than 0. The probability of B given A is N. The probability of B given not A is N. A and B are independence events when... So independent means that they don't affect each other. So the probability of B given A would equal the probability of B. And the probability of B given not A would also equal the probability of B. So that equals M, and that equals N, so M has to equal N. Okay, here, from 1 to 4, and then 2 to 4, then 1 to 2 is equal to. So we've got to get 1 to 2 first. So 1 to 2, that's the same as 1 to 4, and then 4 to 2. So I've got to flip this upside down. So here we would get 4 plus, if we flip this, if we flip the terminals, that's going to become 4 plus 2. So we know that bit there is 6. So we've got to integrate 1 to 2 x dx, which is x squared on 2 between 2 and 1. 4 on 2, 2 minus 1 on 2 is 3 on 2 plus 6, 6, 7.5, 15 on 2, not 7 on 2. The graph of the function passes through the point -2, 7. hx is that graph, then the graph of the function h must pass through the point. Okay, so dilate at factor 2 from the y-axis. That affects my x value, so -4. Translate it up 5, that becomes 12. -4, 12. The weights of lollies are normally distributed with a mean of 200. If 97% of lollies weigh more than 190, 0.97. The standard deviation of the distribution correct to one decimal place is. Okay, so inverse norm, 0.03. That gives you my z value. Z is equal to x, which we know is 190, minus mu, 200 on sigma. Solve for x. 5.3169. 5.3. Okay, let the function 2 to infinity, turning point, I'm assuming that this is going to be inverses, yep. 2 to infinity, f of 5 equals 7. What are they telling us that for? Okay, the function g is the inverse of f. G dash of 7 is. Okay, we know if f of 5 is 7, then g of 7 is 5. But what that means is if we find the gradient at 5, the reciprocal will be the gradient of this at 7. So f dash of x is 2x. (2x minus 4). F dash of 5 is 10 minus 4, which is 6. So then g dash of 7 is 1 on 6. It's reciprocal. Because if you've got a graph like that, so there are swapped x and y, whatever that graph is, this graph, whatever the gradient of that graph is, the reciprocal is that other graph. Okay, part of the graph y equals f of x is shown the corresponding part of f dash of x. This should be alright. Negative, 0, negative, positive after 5. Negative, 0, negative, positive after 5. That looks like a winner. So it goes really negative, goes back to 0, goes down and becomes negative, goes back to 0 again, which is what that bit is. I reckon it's A. Yeah. This one, the significance here is it becomes positive at 5, so it's got to go above the axis, so it's not that one. 17. A box contains n marbles that are identical in every way except the colour, of which k marbles are coloured red and the remainder of the marbles are green. So k is red, green, n minus k is green, because I know I've got n in total. If I take away k, I've got the amount of green ones. 2 marbles are drawn at random from the box. If the first marble is not replaced before the second marble is drawn, then the probability that the 2 marbles drawn the same colour is. Okay, so we've got red and green. The chance of getting a red is k on n. The chance of getting a green is n minus k on n. I either want red, red, or green, green. So red, red is k on n. It's not replaced, so k on k minus 1 on n minus 1. Plus, because it's a different outcome, green is n minus k on n, and then it's n minus k minus 1, because I've got to take 1 away on n minus 1. Okay, so here I've got k minus 1. They've both got the same denominator, n minus 1, plus n minus k minus 1. So chuck it in the k. Oh no, we don't need to chuck it in the k's. It is D. Hopefully I didn't stuff that up. It looks nice. Okay, the distribution of a continuous random variable is defined by the probability density function f, where f of x is p of x. The graph of the function p is shown below. It is known that the average value of p over the interval negative a to b is 3 on 4. Okay, so it's a probability density function. So first thing, the area underneath this has to equal 1. So, if I can get the bloody thing. So, that area, a, 2a times a half. So a half times a times 2a is equal to a squared. This area is a trapezium, 2a, b, and a height of b. So the area, we'll call this a2, a1. So this is a1, a2. Area is a half 2a plus b times b, which is a plus b squared on 2. So we know a squared plus a plus b squared on 2 has to equal 1. We also know if we have that area and we divide it by b minus a, so b plus a, times that same area, a squared plus a plus b squared on 2, that will equal 3 on 4. Okay, let's see if anything makes sense. I'm going to use the same letters. A squared plus A plus B squared on 2. A squared plus A plus B squared on 2. Let's cut it. Okay, so we know we've got to solve simultaneous. Paste. That I said equaled 1. And then 1 on that. 1 on, 1 on, 1 on. 1 on A plus B times that we know equals 3 divided by 4. Solve for A and B. No solution. Nope. That's supposed to be onto. That's supposed to be onto. Yeek. Let's check and see if I've done it right. So, half A times 2A is A squared. A half 2A plus B times B is A plus B squared on 2. A squared plus A plus B squared on 2 equals 1. A squared plus A plus B squared on 2 equals 1. And then 1 over B minus A, so B plus 1, is equal to 3/4. That all looks right. Okay. And then it wanted us to find the probability that x is greater than 0. So that's area 2, which is A plus B squared on 2. So A plus B squared divided by 2, given A is that, given B is that. That doesn't look right. Let's try the other one. So that. No, something's wrong there. What I always tell students, go back, try it again. I don't know what the hell is going on with this thing. Okay. So when you go back, just start the whole question again. This has already taken way too long. Okay. So, A times 2A times a half is A squared. 2A plus B times a half I think I forgot to multiply the B in. I did. So a half A plus 2A plus B times B. I forgot to multiply that by B. Okay, so I've got A squared plus AB plus B squared on 2. Now let's hope I didn't get rid of that. AB times B times B. Okay, so now let's try it. Get rid of that. Get rid of that. So we know A is negative, so it should be this value here. And we know b is positive, so that should be that value. And 1 plus root 2 and 9. No, it's definitely not that. Oh, this is wrong. AB times B. 7 or 9. Okay, see, I should have started the whole thing again. When you have to change things, you stuff it up. Okay, given that tan alpha equals d and d is greater than 0 and alpha is between 0 and 90, the sum of the solutions of tan 2x equals d, where d in terms of a is holy crap. This last one looks nice, so I'm just going to quickly do this first. I taught my class that, what is it called? Chain to base rule. Log x of y is equal to 1 on log y of x, and log y of z is equal to 1 on log z of y. So hopefully 1 on log y of x plus 1 on log z of y, it's d. Okay, last one. Tan alpha equals d between 0 and pi and 2. The sum of solutions tan 2x equals d, where x is between 0 and 5 pi and 4 in terms of alpha is. I don't know how you're supposed to do this, but I think if we graph tan x and tan 2x, now it's said between 0 and pi on 2 and 5 pi on 4, so 5 pi on 4 is larger. Crap. So what I'm going to do is I'm going to put in a line, x equals pi on 2. Okay, and then 5 pi on 4 is obviously the right-hand side, because that's where I put the upper value. Now, we want to look at tan values between 0 and pi and 2, so that would be all of these values here. Now, if I put in y equals d, let's say it equals 2. That's not y. Y equals 2. Okay, if we have a look at that value, this value is half of that value, which makes sense, because you know if you get a solution, if you got tan 2x, you've got to halve that solution. So here, if I halve that solution, so just say alpha is this value here. If I halve it, that would be alpha on 2. So our first solution is alpha on 2. Okay, the same solution occurs here, which is the period apart. So my next solution is alpha. Bloody hell. Alpha on 2 plus the period, which is pi on 2. Okay, and is there any more solutions? There's one more solution, so that'll be plus another alpha on 2 plus pi on 2. So we get 3 alpha on 2 plus pi on 2 plus pi on 2, which is pi, which isn't there as an answer. That's because alpha on 2 is my first solution. To get to my next one, I add pi on 2. But to get to my next one, I've got to add pi, because I've got to add 2 times the period. If I can get this bloody thing to rub out. So plus pi. So then we get alpha on 2, alpha on 2, alpha on 2, which is 3 alpha on 2. And then pi on 2 plus pi, which is 3 pi on 2. So we can take out the 3 alpha plus pi on 2. I think the person on Facebook was full of shit who said it was the easiest ever. I would say that probably 5 or 6 of the multiple choice are reasonably difficult. So, I think a good score would be 14. Yeah, anything above a half. Depends on what you're aiming for. Hope this helps. All the best. I'll be back with exam 2 sometime, extended response sometime. Bye.